Public cloud is an incredible resource for developers today. It brings the ability to provision resources on demand and only pay for what you use. This leads to greater developer efficiency while bringing down overall costs. But what exactly makes up a public cloud? Today, we'll start with an analogy. Say you wanted to bake a pie from scratch. Well, how committed are you? Are you going to make your own flour? Are you going to grow your own fruits? Well, in this society, we've generally accepted that for certain ingredients, you'll go to a supermarket. A public cloud is a supermarket of sorts. It has multiple vendors and multiple solutions, allowing you to pick and choose the right tools and solutions for your taste. Now, to start my explanation on public cloud, I could start by talking about things like infrastructure as a service, or maybe platforms or software as a service, more naturally known as PaaS, IaaS, and SaaS. But instead, I'm going to focus on the overall control and overhead for the different compute solutions that are available in a public cloud. So as the box gets bigger here, there's more control, but that comes with more overhead. Now, let's start with the biggest box, where we've got things like bare metal. Now, with this, you're going to have the most control, but that also comes with a lot of overhead to actually maintain those instances. Let's take it a step higher. Here we've got things like VPC and VMware. So with these solutions, you're going to have a little less overhead because there's automation that allows you to spin up the actual machines. Going a step higher, we've got solutions like Kubernetes and OpenShift container platform. These will allow you to get kind of higher abstraction over the actual worker nodes. The machines that power your actual cluster are basically going to be managed by the platform, and you can focus on writing containers. And going up higher on the list, we get to things like Cloud Foundry, as well as functions, which are going to allow you to focus as a developer entirely on the code and let the platform take care of things like networking and scaling and that kind of thing. So we've got our set of capabilities for compute, but that's not the only thing in a public cloud. You're going to have integrations and services that allow you to start spinning up the capabilities that you need. So today, let's go over a sample application architecture for which we're going to use the public cloud. Now, let's say to start, we have something like a legacy application that relies on VMs or bare metal capabilities. So we'll say over here that we've got VPC and or bare metal. Now, on top of this, we're going to spin up some containers, some machines rather. Now, in those machines, let's say we have our legacy backend application. So we'll scale it out onto 3 different machines. So there we go. We've got our backend pieces. Now, that covers our backend compute for our sample application. Now, let's say for our front-end application, we're taking a model where we have a front-end and a backend for front-end, which are based on containers. So here, it's a little bit of a different model. The worker nodes are going to be managed for us by the Kubernetes or OpenShift layer. So here, we'll have the Kubernetes and our OpenShift layer. Now, on top of this, we can start deploying our containers. So let's say, like we mentioned, we have that front end as well as a back end for that front end application. And for each of those, we want to scale those out, which Kubernetes or OpenShift can handle for us. There we go. So these are the basics of our application architecture. We've got some back-end stuff, we've got some front-end stuff, and all of that is kind of running on some of our compute solutions. Let's actually start taking advantage of some of the cloud integrations that are possible to build out some of the other requirements we have here. First things first, storage. So our front-end application, let's say we need something like, I don't know, a SQL database to actually store things like customer login data. So our applications here are going to use, let's say, a SQL data store. There we go. Now, for our backend application, let's say we need something different, not a standard SQL store, but something like cloud object storage. So here, we'll sketch out a cloud object store instance, which is going to be using, which our backend application will be using. So we've talked about storage. Next, let's talk about DevOps and toolchain capabilities, which we'll also take advantage of our public cloud for. Now, our code is probably split into two different repositories for this particular application that we've got here, our Kubernetes app. We'll say we've got a set of code for the actual containers and applications, and a separate set of code for the actual infrastructure, because we want to manage our infrastructure as code as well. Now, for this, we want to take advantage of some toolchain capabilities. So for our app, we'll take advantage of a toolchain which will deploy our containers. Now for our infrastructure, I'm going to take advantage of a similar toolchain, but in this case, we want to use Terraform, which is an open source way of managing your infrastructure as code to actually manage the infrastructure. So in this case, this will manage spinning up the worker nodes as well as the Kubernetes layer. So there we go. We've talked about so far storage as well as DevOps from our cloud. Next, let's talk about having a central maybe logging or monitoring solution for our tools. So we've got our backend application here as well as our front-end application. And for both of those, we want to stream to a central logging store. So let's say I've got a logging service that I've created here. And that's going to be our central source of logs for both our application running on Kubernetes as well as our backend application running within VMware or bare metal or VPC. So there we go. We've talked about central logging now. Now the next service that I want to take advantage of is thinking about things like networking and security. So in this sample architecture, for our backend piece, let's say we've got really private data. We want to make sure that access to that backend piece only happens over private endpoints. And for our front end piece, we don't care quite as much. We can access over the public endpoint. So making kind of like a bisection here, we'll say that this is entirely private endpoints only, and this side, we can access our data over public endpoints. Now, this doesn't mean our data is insecure. We can still use something that allows us to bring our own keys to secure our data with our own kind of certs and keys. So both of these environments are going to be completely secured. But by making this bisection, how does our front-end app now start talking to some of those back-end capabilities that we've got? So again, we can tap into our cloud and take advantage of something like a VPN gateway. So here we go. We'll set up a gateway so that our front-end and back-end can start talking to one another. Now, this is just scratching the surface of the capabilities that are available in a public cloud. We haven't even begun to talk about some of the artificial intelligence, machine learning, data analytics and insights, and so many other services that are available in a generic public cloud. Thanks for watching this overview of public cloud. If you have any questions, please drop us a line below. If you want to see more videos like this in the future, please like and subscribe. And don't forget, you can always get started on the cloud at no cost by signing up for a free IBM Cloud account.